Good evening, one and all. In today's session, we are going to deal with the operations on two-dimensional arrays. So yesterday we have seen how we can initialize two-dimensional arrays and how we can accept the values of the elements of the two-dimensional array dynamically, that is at runtime from the user through the keyboard. So we will first revise that in brief in the beginning. So as we know, two-dimensional arrays can be used to represent matrices. That is a combination of rows and columns. So and it is written or initialized in the form of row by row. And you can store it in memory in the form of row major or column major. Row major means you want to store the elements row wise in the memory. As I've mentioned that memory of your computer is linear. So you cannot represent or store a table directly in your memory. You have to store it in a linear fashion. So if you want to store rows by rows, then the first row, that is 4 and 3, will be stored. After that, second row 5, 6, then third row 8, 9. This is row by row, so row major. If column wise you want to store, then first 4, 5, 8 you have to store, and after that next column is 3, 6, 9 that you will store. So this is row and column major. We have seen using the formula how to find the address of any element, both for 1D and 2D array. Now, if you observe in this slide, on this slide, we have a particular way to access an element, that is using the index. Now in one dimensional array, you have only one index, like a of 3 or a of n minus 1 or whatever. So only one index. Here we have two indices. That is, one is row index and the other is column index. Whatever you write first, like if I say a of 0, then the first 0 is row index, second is column index. Similarly, if I say a of 3 of 1 means what? Row index is 3, column index is 1. So it will be found in the row which has the index 3 and in the column which has the index 1. Now, remember that the total number of rows in an array should be specified during initialization or declaration. Similarly, total number of columns of an array should be specified in initialization or declaration. But you can access a particular element by using the same syntax, and that does not indicate the total number of rows or columns. For example, let me show you. If I say a of 4 of 5, and this is my initialization part or declaration in this case, this means that total number of rows is what? 4, and total number of columns is what? 5. But suppose I want to write sum is equal to sum plus a of 2 of 1. So this means, and if initially sum is 0, then sum is equal to 0 plus a of 2 means the element in the row index 2 and the element in the column index 1. That element I want to access. Here 2 doesn't mean it is the total number of rows. But in your initialization declaration, whatever you write in your square bracket means total number of rows, total number of columns. Is this clear? Yes? Am I audible?
Yes.
Yes.
Okay. So we have seen this last time also. Now tell me another thing. Suppose I write int a of 4 of 5 and I want to access or print the value of a of 5 of 1 or 2. So do you find any error in this? Or is it okay? Can I access this particular element?
No,
Why no?
because
Anyone?
there are there are four rows, right?
Yes. And I am trying to access the row number 5. Means in memory, how it will be. Suppose I write here rows. Okay. You can have, since my total number of rows are what? 4. So index will go from 0, 1, 2, and 3. Okay. Means total I have how many row indices? 4 indices. And my columns are total 5. That means I have to start from what? 0. So 0, 1, 2, 3, 4. Okay, total 5. So as you can see, if I write here 5, it means I'm trying to access row with the index 5. But maximum index of my row is 3. I cannot have 5. Now I'm trying to access the column with index 2. That is possible because 2 is there in my possible value. Okay, have you understood this?
Yes.
Okay. Now, one more thing. Uh, Now I'm not like, it's not a compulsion to for this, but do you know what is an identity matrix?
Yes, where all the elements are one.
All the elements or only particular elements? Yes, diagonal elements are only one. Yes, yes, I got it. So only diagonal elements are one and all the others are zero. Now, in this, as we can see, diagonal elements will be what? 0, 0, a of 1, 1, a of 2, 2, and so on up to a of n minus 1, n minus 1. So as we can see, if the row index is 0 and column index is 0, means row and column index is same. Then row index is 1, column index is 1. Row index is 2, column index is 2. Means if I is equal to j, that is the row index is equal to column index, then we can say that element is an identity element or it is present in the diagonal of the matrix. Now we always consider diagonal from 0, 0 position to, let this way, means upper left to bottom right. That is called as a diagonal which we are interested in. That is known as major diagonal. Okay, this is just an extra thing that I'm telling. This is called as major diagonal. There is also a minor diagonal. Minor diagonal is from top right, that is this position, to bottom left. Okay, this is called minor diagonal. But whenever we say diagonal, we want to access the major diagonal. Okay, we usually never access minor diagonal. Major diagonal is from 0, 0 to last position, upper left to bottom right. So this we have studied in maths and that we can implement in programs. Okay, so that's why I'm telling you. Now let us get to the programming part. We know how to accept the arrays from the user. If it is two-dimensional arrays and if it is one-dimensional array. Now, if it is two-dimensional arrays, we need two for loops, right? If it is three-dimensional, we need three for loops, and so on. Use printf to tell the user to enter the element. Use scanf to initialize that element. Through scanf, you can initialize an element, right? And then you can print the elements using another pair of for loops. Okay, first accept everything using two for loops, and then print everything using two for loops. Why two separate sets of for loops I need is because, see, when I accept my elements, I will not print them directly as soon as I accept. Why? Because then I'm accepting and printing. So we won't, it will, like, it is duplicate values will appear on the screen, right? I accept some value, so I will enter 2. Next line, what will be, it will tell the user has entered 2. Then it will tell me enter the element, I'll enter 3. Then you'll say user has entered 3. So duplicate means double times I'll get to see everything. So what you do, once you accept everything, and then together whatever you accepted, print it using the next set of for loops. So let me run this program once and show you. So this is for accepting the values and next is for displaying the values. So say accepting the elements, enter 0 0, that position element a of 0 0, then enter row will be same. Okay, means how it is. First I'm accepting for the row 0. Now in the row 0, I can have the column 1 element. Okay, means okay, this is row 0, column 0. So I'll accept this element first, suppose 2. Then row index is same. I'm accepting column 1 element. Column 1 element, suppose I enter 3. Then column 3 element I'm accessing. Suppose I enter 4. So row index will be same. And within that row, for each column, within that row, for each column, I have to accept the elements one by one. Then when total number of columns is complete, what will happen? Row index will get incremented. Row index will become 1. And then I'll accept again column 0 element which lies in the row 1. Column 0 element which lies within row 1. Suppose I enter 21. Then within row 1 itself, column 1 element I will accept. This is how it is running. Then within row 1, column 3 element I will accept. Okay. Then again for column 2, column 3, and so on. So it is accepting how from left to right, then again left to right, then again left to right, and so on. Okay, so this is how it is accepting. That is why row index is remaining same for the number of columns. Suppose 5 columns are there, then the row index will be 0 itself for 5 times. Then row index will become 1 for 5 times. Then row index will become 2 for 5 times. Okay, for the total number of columns, that many times your row index will remain same. For example, here the size of my array is 3, 3. So I have 3 rows and 3 columns. So I have 3 columns. So 3 times the row index will remain 0, as you can see here. Okay, 3 times it is 0. Then row index has become 1. Okay, 3 times it will remain 1 because there are 3 columns that I need to fill. Then again row index becomes 2, and 3 times it will remain 2 as the column index increments. Okay, this is how. And then finally whatever I entered, that is getting printed. So what I have entered, 2 3 4. So how it was getting stored in memory, 2, then 3, and then 4. Then I have entered 4 5 6. So how it is stored in memory, 4, then 5, and then 6. Then row 2, I have entered 5 6 6. So 5 6 6. Okay, so this should be your matrix. Okay, 2 3 4 4 5 6 and 5 6 6. 2 3 4 4 5 6 5 6. Okay, so the way that we have executed our program is correct. Have you understood this?
Yes.
Yes.
Okay,
Yes.
very good. Now this was the program that we just now executed. Now can you tell me if you know what is transpose of a matrix? Anyone? The rows become the columns and the columns become the rows, right? Transpose means rows becomes the
Yes.
column and columns
Yes.
become the rows. Yes. So what will happen for this example? 2 3 4. I'll write it once more. Okay, so now what I'm going to write is your transposed matrix. This was your original matrix. If you want to find the transpose of the original matrix, say A, then its transpose can be expressed as A raised to T. Okay, this is how we denote it, A raised to T or A bar or a complement, we can say like that. Okay, so let's say a raised to t, means t is the superscript. It is like a raised to t. Okay, so 2 3 4 is your first row, it becomes your first column. 2 3 4 4 5 6 is your second row, it becomes your second column. And 5 6 6 is your third row, it becomes your third column. Okay, so this is also called as a square matrix because number of rows is equal to number of columns. 3 rows, 3 columns, so it is also known as square matrix. Now, this we can do in the help of a program also, transposing. The simple way is, here when we were printing a matrix, what we did, outer for loop is controlled by variable I, inner for loop is controlled by variable j, and we are printing a of I of j. Now, if we want to transpose, simply print a of j of I. Okay. Till now we were printing a of I of j. Simply print a of j of I. Means what will happen? Let me show you. See, now here what is it? I is equal to what? 0. And j is also equal to 0 because a of 0 0 is my first element. So if I interchange I and j, what will it be? 0 0 only. So this element will be here itself. Now what about a of 0 1? So here I is equal to 0 and j is equal to 1. In transpose, what will happen? I will become 1 and j will become 0. So the element at 0 1 will be placed at the position 1 0. Okay, so this will come here. Similarly, a of 0 2 and a of 2 0. These two positions will get exchanged. Similarly, a of this one and finally this one. These two means diagonally they are getting interchanged. Similarly, here you have a of 1 of 2. It will go at position 2 of 1. That is this one. Okay, similarly 3 of 2 will go at 2 3. Where is 2 3? 2 3 is this one. Okay, so diagonally each element will get exchanged. Diagonally means which diagonal? Your major diagonal, this one. About this, these two will get swapped, then these two will get swapped, then like this. Okay, diagonally all the elements will get exchanged. I hope you understood this. So simply make I of j as j of I. Okay, so in transpose what we do, I of j becomes j of I. So that's what I have done here. Okay, so let us execute this program and see. So I enter the elements of first row, then second row, and then third row. Why? Because row wise the elements get stored in memory. And then this is what has got stored. Okay, currently original matrix 3 4 5 5 6 6 and 5 6 7. And now I want to print it in the reverse order. See here, I've entered 2 3 4, then 5 6 7 and 7 89 0. So 2 3 4 5 6 7 7 89 0. So now what should be your first column? 2 3 4. That is your first column, 2 3 4. Second column 5 6 7. Second column 5 6 7. And your third row, that is 7 89 0, has become your third column. Okay. So I hope you understood this. Have you?
Yes.
Yes.
Okay. Now this is just printing. Now if you want to store this transpose into another matrix, what can you do? Any suggestions from your side? Here what I'm doing, I'm simply printing A of j of I. If I want to store this whole thing in another matrix, what changes I have to make? Can you just suggest me? See, it's a simple thing that you have to do. You have to take another array, say BRR, same size, okay, same number as of your original matrix. That is 3 by 3. This is also 3 by 3. But you have to declare it. Don't initialize it. And now what you do in your for loop where you are printing j of I instead of I of j, what you have to do, BRR of I of j is equal to ARR of j of I. Okay, so ji element is getting stored as ij position element. Okay, have you understood this? Yes.
Yes.
Yeah. So when you print your BRR array, it will give you the A transpose. So let us try that as well. Am I going fast or is it okay for you, or should I increase my speed? Yes.
It's okay.
Okay. So while printing, you have to print BRR of I of j only. Okay, not j of I. So for us to understand, let me print one message here. Why do I use backslash n? Can you tell me?
It's providing
New line
space.
command.
To
Yes.
go on the next line. It is called as new line character. So let me enter my elements again. Okay, so this is my matrix which I have entered 4, 5, 6, and BRR matrix holds the transpose. So 4, 5, 6 becomes the column here. Row 2, that is 6, 7, 1 becomes column 2, and column 3, row 3 has become column 3. So this is the way you can store one matrix in another matrix. Now Now we have seen how to traverse an array. Traverse an array means you want to access each element at least once. So this is a, which is the data type of this array? Can you tell me?
Character.
Yes, it is character. So it is an array of size 5. So I can store 5 elements. If I store more elements, they will be stored in memory. But using this array, I will be able to access only the first 5 elements. For example, I can store F and then G and so on. Okay. Now one more thing before I proceed. A is in single quote and I've written G in double quote. Which one is the correct way to store a character?
Single
Single quote.
quote.
Yes. In Python, what is it? Is it the same or is it different?
Both are same.
Yes. In
Same.
Python, single and double, it will give you same result. But in C, C++, Java, for character single quote, for a string that is a collection of characters double quote. So if I write a single character in double quote, like G in double quote, G is considered to be a string. Okay. But you should not write single character in double quote. Now, if have stored how many 1, 2, 3, 4, 5, 6, 7 elements, they will be present in memory. But if I want to access from the letters array, I can access only first 5 elements. Similarly, if I store lesser number of elements, the remaining values, let us print let us see what happens when we print it. See, you're getting only those three letters A, B, C. Okay. Now, forward traversal means left to right. Forward means left to right. So you want to print from I is equal to 0 till I is equal to 4, means I is less than 5. So A, B, C, D, E, this will get printed using this for loop. Okay. Now backward traversal means what? I want to print from right to left, that is E, D, C, B, A. So what should I do? I should start i's from the value of I. If I want to go forward is what? From 0 to 4. If I want to go backward, what should be the starting value of I? Can you tell me?
Uh,
It should be n minus 1, right? Because index goes from 0 to n minus 1. Forward traversal means 0 to n minus 1. Backward travel means n minus 1 to 0. Okay. So this was backward traversal. So as you can see here, my for loop will start from n minus 1. Since here I have stored how many elements? 5. So 5 minus 1 is equal to n minus 1. 5 minus 1 is 4. So I is equal to 4 till I is equal to 0. And here I will decrement. In my forward traversal, I is 0, then it becomes 1, 2, 3, 4. This is increment. I is equal to 4, then it should become 3, then 2, 1, and then 0. So this is decrement. I minus minus. So now you can use this index to print the array. Okay, you know how to use for loop to print an array. So let us run this much and let me show you. See here, we have executed only two for loops, that is this one and this one. So ABCDE using forward traversal and EDCBA using backward traversal. So first I was 4. So letters of 4, letters why? Because letters is the name of the array. Letters is the name of the array. So letters of 4 was printed, that is E. Then letters of 3, letters of 2, letters of 1, and letters of 0. So this was forward and backward traversal. Now this is just printing directly. I'm just printing it in the reverse way. What if I want to store the reversed array in another array? Okay, I want to store the reversed array in another array. So how will I do it? Here,
initialize second.
yes, tell me, how will I do?
Initialize second array.
Initialize it to what?
Different array. Making different array.
Yes, in the different array, I have to initialize the first array or original array. So in backward traversal, we have to start from n minus 1 up to 0. So that's what, see the value of I. I is going from 4 to greater than equal to 0. So 4, 3, 2, 1, 0. Now why have I used this another variable in J? Now this syntax is valid within your for loop. You can have multiple initialization part, multiple condition checking part, and multiple increment decrement. Increment decrement is known as step size. Okay, by what? In steps, how you climb, either you climb the steps or you get down the steps. So if you want to increase your this counter, that is you're incrementing. If you want to decrease it, it is decrementing. And by how much you're decrementing, that is known as step size. Means maybe you can climb 2 steps at a time. So j is equal to j plus 2 I can write if you are climbing 2 steps at a time. So it is called a step size also, or normal way increment decrement. So in my reverse array, okay, this array will store the reversed traversal or the backward traversal. In this array, I have to store my original array, but in the reversed way. So let me dry run it or hand run it. Means without executing the program, let us try to understand what will be the output. See here, for loop is beginning at I is equal to 4 and j is equal to 0. There are two initializations here. Now, I is equal to 4, it is greater than equal to 0. And j is equal to 0, it is less than 5. Okay, these are my conditions. It is true, so the for loop will get executed. What will happen? Reverse of j into is equal to letters of okay, so reverse of j is equal to letters of I. So the current value of j is which one? 0. That will be equal to means whatever is at the right hand side, that will get stored in the left hand side, right? It is not your mathematical equal to, it is whatever is at the right will get stored in the left. So it will be equal to letters of I is equal to what? Can you tell me? Yes, it is 4. So this will be letters of 4 is what now? Let us see the array. So 0, 1, 2, 3, 4. Letters of 4 is E. So the character E will get stored at 0th position or index of reverse. So now I am building my reverse array. So let me write here. The size of reverse is equal to original size. And I've entered the first element E. Now what will happen? I will get decremented. Okay, so I will become what now? I will become 3. And J is getting incremented. Okay, so J is now 1 and I is now 3. So what is letters of 3 now? It is D. So I have stored my character D at reverse of 1. Okay, so E was stored at reverse of at the index 0 and D is stored at the index 1. Now next what will happen? I will again get decremented, J will again get incremented. So that will be reflected here. So now letters of 2 is what? It is C, and that I'm storing at reverse of 2. Okay, so this way I'm storing it reverse in my reverse array. So after C, you can store B likewise and A. So this is how I have stored the reversed array in another array. And then I have to print this reversed array from left to right only. If you print it from right to left, it will be equal to your original array. Your original array is letters is equal to A, B, C, D, E. I have reversed it as E, D, C, B, A. If you reverse your reversed array, you'll get your original array. Okay, so you have to not do that. You have to print from left to right your reversed array. That is from 0 to 4. So when you print it, you will get it. See, this was our forward traversal. This is our backward traversal. And this is backward traversal and storage. Why and storage? Because I've stored it in another array. So printing it the reverse way and storing it the reverse way should give you the same output. Now, if you have seen my videos, you definitely know what is palindrome. What is palindrome? Can anyone tell me?
It is same even if we reverse the letters or
Yes, very
numbers.
good. It is the same. Either you read left to right or right to left, you will get the same output. So, yes. So that is what I'm checking here, whether the left to right, that is forward traversal, is equal to the right to left, that is reverse traversal or not. So now I have built my reverse array. I already have my letters array. So what I have to do, same for loop that I've used here, where I've used two variables, I and j. That same thing I have implemented here, same for loop, and I have to check whether reverse of j is equal to letters of I or not. Okay, reverse of j and letters of I have to compare them using double equal to. Means I have to see whether the values in these positions are same or not. Okay, so for example, here letters of 0 is A, but reverse of 0 is E. So this is not palindrome. Suppose I have it as now this is my letters array. Suppose 1, 2, 2, 1. If I read it from right to left, what will it be? 1, 2, 2, 1. So here at letters of 0 and at reverse of 0, I have 1. At letters of 0 and at letters of 1 and reverse of 1, I have 2. At letters of 2 and reverse of 2, I have 2. And at letters of n minus 1 and reverse of n minus 1, I have 1. So this is how I have to compare. Okay, because whatever I've stored in reverse array is the reverse of the original array. So I can compare directly. Have you understood this?
Yes.
Yes. Others?
Yes.
Yes.
Okay.
Yes.
Yes. Now there are two ways to check this. We are comparing till then we have seen. Now how to check whether we have to stop comparing or no? Because even if one position the element is not matching, then we have to stop comparing, right? Unnecessarily we have to not compare the all the elements. As soon as we find an element, if it is not in the correct position, that is if it is not matching, that is if it is not equal to, we have to stop. So we have to break the loop. So how can we come out of the loop? Which keyword we have to use?
Break.
Break.
Yes, we have to use break. So that is one way that I'm discussing right now. So how that will work here? After that, we'll see the above method. If reverse of j is not equal to letters of I, means what? As in our previous condition. What we are comparing here, see, letters of 0 and reverse of 0 are not equal. Okay, so if condition is satisfied, so I'll execute the statements of if condition, that is break. So what will happen? I'll come out of this loop. Why? Because the elements are not in the correct position as required. So as soon as I come out of this loop, I can print that. Means there are two conditions now. If I can either come out of the loop in between, or when can I come out of the loop? When the condition is not satisfied of for loop. Means what I'm saying. Now in this condition, what first position elements are not in the correct position. So I came out of the loop in the first execution itself. In the first execution of the for loop itself, I came out of the loop. Now if I have the array as this one. So what? Letters of 0, reverse of 0 is matching. Letters of 1, reverse of 1 matching. Matching, matching. Now for loop the variable I and j how violated the condition, means it has become equal to 5 over here. So my for loop gets terminated. That is how for loop gets terminated. So that time if I will definitely come out. So that time I should not print that list is not palindrome or if it is palindrome, because if all the executions of the for loop are performed, means I have not come out of the for loop in between. If all the executions of the for loop are performed, means this if condition has never got satisfied. If all the conditions of for loop have been executed, means my list is a palindrome. So that time I should, when can I say this? When I is equal to 5 and j is equal to 5, that time the for loop gets terminated because the condition is violated. And that time if that is the case, means it is a palindrome. But if my I is 0 and j is also equal to 0, this is not the termination condition. What is my termination condition? Less than 5. Means if I becomes equal to 5 or j becomes equal to 5, that time my array or my for loop will terminate. But as long as 0, 1, 2, 3, 4, my for loop will run. So if it is 0, 0, And if it is not matching, then I have broken the loop. So it is not palindrome. But if I has become 5 and j has become 5, this for loop termination has reached. So I have come out of the loop. It is not that I have broken from the loop. It is because execution has stopped. So I have come out. I have not come out in the middle. If I come out in the middle, it is not palindrome. If I come out at the end, it is palindrome. Have you understood this? Whatever I have said till now?
Yeah.
Everyone?
Yes.
Yes.
Yes. So when can I say it is palindrome? When I is equal to 5, j is equal to 5. Because that is the time I will come out of the loop because the condition is violated. I am not breaking out, I am coming out because that is the termination of condition of for loop. So that is when I is equal to 5 and j is equal to 5, I can say it is palindrome. But if I is equal to 0 and j is equal to suppose 1 or 0 itself, that means I have not reached till the end. That means in the middle I have come out. That means list is not palindrome, else part. Okay, have you understood? How can we check this? Or should I repeat? Yes?
Understood.
Okay. So this was one way how you can check for palindrome. Another way is what? This one, using flag. So flag is like an indicator. So above in my program, I have initialized flag to 0. And in my condition that if reverse is equal to letters, then I have to increment flag. Means what? I'm getting the correct match. A, A. So this if condition is satisfied, and that time I will increment flag. So flag will become 1. Then again my loop will run, I'm getting B, B. Flag will become 2. Then it will become 3. Then it will become 4. Okay, so 1, 2, 3, and 4 in this case. Now here we had A, B, C, D, E. So what will happen? If first time it is checked, then it becomes incremented by 1. Flag becomes 1. For second time, flag becomes 2. Then flag becomes 3. Flag becomes 4. Flag becomes 5. So when flag becomes 5, if flag is equal to 5, if flag is equal to 5, that means you know that if I is equal to 5, j is equal to 5, I have come out of my for loop. And if flag is equal to 5, means I have executed each time the for loop, and that means the list is palindrome. But if flag is not, that means this condition is not satisfied, then flag will not become incremented by 1. Okay, in between, if flag is if the condition is not satisfied, then flag will not be incremented. So it will not reach 5, and then I can say that list is not palindrome. Okay, have you understood this? Yes. Okay,
Yes.
what about others?
Uh,
Yes,
but
tell me.
but in that
Yes.
in that code, it has like the code is limited for only those arrays which have 5 elements,
Yes. Yeah.
right? So if user want to put entry the elements of that
Yes.
array, so what would be the code for
Yes,
that?
I was about to show you that in our next program. So this is for when you know the size, when you have initialized your array. So these are the two ways for checking palindrome. Okay, so you know how to initialize an array, you know how to accept an array, you know how to reverse an array, you know how to check palindrome, you know how to find the sum of elements of array and product. Now, as you have asked me, and as I was going to show, what if the size is determined at runtime? That means user has not decided in the beginning how many elements he wants to enter. So that time what will happen? You can find the length of your list. Okay, so in such cases, you must calculate the size of your array. See, for example, here you have the elements 1, 2, 3, 4, 5, 6, 7, 8. And here, if I don't initialize the size, okay, here I have written empty square bracket. Okay, it will work in C language, C++ language, because the compiler automatically computes or finds the size of your array. Here there are 8 elements. So automatically the size over here is by default 8. The compiler will understand. You don't have to specify. Okay. This is a new thing that I'm telling today. By default, the compiler will find out. Okay. For if you're initializing. Okay. Only if you're initializing. But how will you come to know the size now? Because you have not initialized it right here. Because compiler will do it automatically. Compiler will not tell you that, okay, the size is 8. How will you come to know? So for this, there is a formula. Now, whenever I write size of, it is used to find how much memory the variable or the entity is occupying in the computer or in your device. So if there are 1, 2, 3, 4, 5, 6, 7, 8 elements, and each element is an integer type. So how many integers I have? 8 integers. And in my machine, integer will occupy 4 bytes. So there are 8 elements. One element occupies 4 bytes. So 8 elements will occupy 8 into 4 bytes, that is 32 bytes. So if I write size of ARR, this syntax, then it is equal to 32. This value is 32. And suppose I write size of ARR of 0. What is ARR of 0? A single element 1. Size of 1 is what? 4 bytes. So 32 divided by 4, that is 8. And 8 is nothing but total number of elements in your array. So this is one way of calculating how many elements in your array. Now suppose you don't want to take ARR of 0. Okay, you can take ARR of 5 also. So ARR of 5 is what? This is 0, 1, 2, 3, 4, 5. So element 6. 6 is also integer. It will also occupy 4 bytes. So here this will be 4 and this is as it is 32. So take ARR of any index. Okay. Usually we take 0, but you can take any index. Now what will be the problem here? Since in C++ Java, your arrays are of homogeneous data. That is same data type. Each element is of same data type. So this is okay. You can take ARR of 0, ARR of 5, anything, because everything is an integer. But in Python, what happens? You have maybe integer, next element can be a character, next can be a string. So each element has different size. So there this formula will not work. Are you getting it? Yes?
Yes.
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 Okay. So this is how you can calculate size for C++ Java arrays. And then you can, that I'm storing in n. Now size is always a positive number, right? So you can have a modified integer variable like unsigned int. I have shown you the data types in my unit 2. There unsigned means the integer value that you're storing in unsigned int is always a positive value. Okay, if you store negative value, then the negative part will be discarded. It will be considered positive, and your value may get altered. Okay, that we will see in our future lessons. So here unsigned, if you don't give unsigned also no problem. Okay, so then I can print the value that array size is 32 divided by 4, which is 8, which is stored in n. Okay, so this is how you can explicitly, means you, that is the programmer, can calculate size of array. Okay, now one more thing, let us test something now. Suppose I have only declared my array. Okay, in such cases, if I don't specify the size in square brackets, let's see what will happen. Okay, so yeah, here we have seen how to accept an array from user. Let us modify this code itself. As you can see, I have not specified the size. I have declared this array. Now I will tell the user, enter the number of elements you want to store. Enter the number of elements. Okay, then in my scanf, I will accept the total number of elements that the user wants to store. Suppose I store it in n variable. Now I know that the user will enter how many elements, whatever is stored in n. Suppose n is 5, then the user can enter 5 elements. So this 5, let me replace by n. Okay, so if n is equal to 3, it is nothing but I less than 3 will come over here. If n is 5, I less than 5. So I less than n. Okay, we are testing this. I cannot guarantee whether this will work or not at this point. We are testing it. So for now, let us just accept the array. See, it is giving you an error. That means, see, what is the error? Size missing in A. That means you must specify the size. So if you are specifying the size and you are asking the user enter the number of elements, suppose user enters that he wants to store 2 elements, then this array can hold those 2 elements. Suppose size is 4, user wants to enter 10 elements. So what will happen? Only first 4 elements will get displayed. Maybe. So let us see what will happen. Enter the number of elements for those many times I'm entering the for loop. Now, but my size I've initialized to 4. Let us see. So program is running. I want to enter 6 elements. Okay, so I'm entering. How many elements I got to enter? 1, 2, 3, 4, 5. That means, just a minute. User wants to enter 6 elements. Okay, I got to enter 6 elements. Now, I have entered 6 elements. But let us say when we print the array, what happens? Okay, so how many the user wanted to enter n elements, for those many times I will print the array. I will try to print the array. So suppose 6 elements. See here, you are not getting the desired output. 3 and 4. These are first 2 elements only you're getting you're able to display. So what happens? It may give undefined behavior when you do such things. Okay. Now this was one case. Now another case can be, if I tell enter the number of elements, user enters, I want to enter n elements. And after this, I can do one thing. After this, I can initialize my array. Now I'll write int a of n. Okay. So a of n. How I know what is n? I've told the user, I've entered the number of elements you want to store. User said I want to store n elements. So I have declared an array of size n. Okay, this n over here and this n is same. Now for n times, I will run the for loop to accept those elements. And then for n times, I'll execute to display those elements. So let us see what happens here. User wants to store 6 elements. So n is equal to 6. And now I have declared my array as ARR of n, that is ARR of 6. So I'll enter my 6 elements. See, I've entered 6 elements and I'm able to display those 6 elements. So what we understand that for dynamically stored arrays, or at the runtime, the user wants to decide how many elements he wants to store. He doesn't know in the beginning, while designing the program, he doesn't know how many elements he wants to store. While he's executing, he wants to keep on changing the number of elements that he wants to store. So what you have to do, this is the code. Ask the user or the programmer that enter the number of elements you want to store. That will be stored in the variable n. Then declare an array of size n. Then execute a loop n times to accept n values. Then execute a loop for n times to print those n values. So have you understood? Initialization at compile time, that is at the designing of the program time, and initialization at the runtime. They are two different things. Have you understood this?
Yes.
Okay. So we can stop for today over here. If you have any doubts related to recorded videos up till now, or related to the live sessions, or related to today's live session, you can ask me now, and you can put your attendance in the chat box. Name, roll number, and division. Any doubts? And have you all seen the video of pointers?
Yes,
Have you
pointers and
understood?
memory.
Yes, pointers and memory. Have you understood or do you have any doubt in pointers?
Yes, I've understood it.
Okay. So if others have not seen, they can also see. And as and when you get doubts, means I expect you to see the videos as soon as possible, so that as soon as possible you can ask me your doubts, because these concepts we will need in future. So it is better to master these topics when there is time and when you have time. So
So
if
can
you
you send few questions of related to that topic so that we can solve
Yes, okay, okay,
practice?
I will send you. And that is just one part of the chapter. There are some other videos of that topic that are to still prepare. So these are basics. So once you understand these, again and again you can watch that video so that you can understand. Then I'll upload the remaining pointer videos. And I'll send you assignment questions for your practice. Any other doubts?
No.
Otherwise, if you don't have doubt and you put your attendance, you can leave this meeting. Thank you.
Thank you.
Welcome.
Thank you.
Welcome.
Thank you.
Welcome.
Can you also put the PDF of today's and yesterday's session on that
Yes.
Excel
Okay.
sheet?
Yes, I will put.
Okay, thank you.
Yeah. Welcome. Any other doubts?